So the next unit is ICTNWK507, install, operate and troubleshoot medium enterprise routers. This unit will be looking out is about routers configuration, knowing routers, how routers work in a network. So overview, prepare to install a medium enterprise router, configure basic router operation, configure and verify the dynamic classless routing protocols, apply sound troubleshooting processes to determine network connectivity. So first, prepare to install a medium enterprise router. This uh, prepare for given work. Okay, this is for assignment 1.1. I believe you've already done it, right? If you do not need, we have some areas of focus. Okay, legislation, some legislations that you can refer to: workplace health and safety laws in Fiji, okay, code of conduct, okay, regulations and standards that will be in there. So arrange access to the site, okay, according to the required procedure. Physical access is mentor, security guard log, remote access, telnet, SSH, VPN, loggings, administration and monitoring, least privileged access, and wireless access. Review existing network design, okay, to ensure it is the current and complete. Can be a single or series of documents. Okay, so areas of focus: infrastructure, devices, peripherals, software, administrative, and diagrams. So basically what we are looking at is if you have already a setup, if how you can review it, if there is any flaws in that setup, what is some of the things that you can do to make it perfect. Okay, select the network elements required, okay, to be installed to meet the technical requirements. Okay, technical requirements would be from the organization, what the needs of the organization would be. So areas of focus would be your network devices, the type of network devices you have, network media, endpoints, peripherals, and hardware. Right. Also, in here you can see the uh, which type of wired network is used, the types of cables, and which waves for wireless. Okay, contact vendors and service suppliers, okay, to be obtained for specification and availability of identified components. Some vendors are listed there. You can also look for local vendors if there are any. Okay, for instance, in Fiji, if you find any vendors that can help, please do contact them and try to get those technical specified devices for your network. So develop plans. Okay, so with the prioritize uh, tasks and contingency arrangements for installation of components with minimum disruptions to clients. These plans need to um, name the project, break down the project into steps, identify and allocate resources to the project, give timelines for projects, state who will take the appropriate action, develop contingency plans, and list desired outcomes. With all these in plans, you're working on for your development plan. So this is a brief breakdown of how you could be planning. Okay, so your name of, for example, the name of your project could be digital infrastructure for schools in a remote area. So phase one will be determine the client's requirement. Phase two, plan and design new IT infrastructure, and plan to build, install, and configure the new IT infrastructure. Going into phase four, test, verify, and monitor operations, and finally complete documentation and closure. Right. So liaise with appropriate person to obtain approvals for the plans, including security clearance and timing. Okay, so the stakeholders that would be required, you have to take approvals from them, your managers, the CEO, to get the your project going. Right, configure basic router operations. So routers, what is routers? Okay, a router is a networking device that forwards data packets among computer networks, hence guiding network and website traffic efficiently. Data packets are forwarded from one router to another through an established interwalk until it reaches its destination. Enterprise routers are basic products that any business or enterprise use, as they play an important role in connecting computer networks and the internet. Routers have many uh, functionalities. For example, enterprise routing gives business higher CPU capacity to control place tasks. As well, it gives businesses the ability to enhance their interface for both Ethernet and WAN circuits, run net flows as flows, okay, MPLS, QoS, and security features. Installation of an enterprise router requires the skills and expertise of a network professional due to its complexity. Enterprise routers have numerous Ethernet ports which handle millions of data packets per second and comes in different sizes based on the business size and their typical data usage. So basically this slide has explained what a router is in a actual WAN, what type of router is used, and we have routers also in homes, those small routers, the unwired routers, your Vodafone, TFL routers you use. But those small routers you cannot use to run a big WAN. Okay, it will just not be able to cater that much of data traffic. So for WANs, we need a specific router, big router that can handle all those. Right. So you have an assignment on this slide, assignment lab 2.2. Okay, so types of routers. Key factors when choosing an enterprise router is speed, form factor, software, size, reliability, security, and price. Okay, routers are not cheap. Can cost around about $3,000 to $4,000 for a router. Cisco System, one of the top networking companies in the world, Cisco routers can empower your business network to become more insightful, responsive, and incorporated with the use of the adaptive and aligned technology. Okay, most of the routers used in Fiji are Cisco. Most. Okay, so Cisco integrated service routers branch enhances Cisco scope of work. Branch office routers by integrating multiple system services into a single platform. Some of the Cisco routers are listed there. Cisco WAN aggregation router, okay, boosts superior IP along with scalable and compromised IP service at the network's edge. Cisco Internet Edge routers are specified routers situated at a network boundary which empowers campus networks to associate with external networks. These edge routers are essentially utilized with the focus of two divisions, okay, WAN on the web. Cisco Integrated Service Virtual Routers. The Cisco Integrated Service Router ISR is a part of the Cisco borderless network architecture which empowers business innovation and growth in all remote sites. So you can see you have routers for different specifications, right? If your business is on more on web based, you WAN is more on web, so you'll have to go with the Cisco Internet Edge router. If it's more with, you have workers who are working more from remote sites, so you might be having to have a virtual router. Other vendors for enterprise routers include Juniper, HPE, Dell, Nokia, Avaya, and Huawei. So OSI model, as you can see, you have 7 layers of the OSI, right? So I will not be going over this because we have already covered on the OSI model. Also the TCP IP model, this had been looked in the client and server cluster. What is TCP/IP model? So installation required. Okay, so requirements for installation. So appropriate media cables, ports, connectors, and tools are required, and manuals. So if you go to the there is a hyperlink for Cisco installation guide. You can have a read through, and also this is one of the kind of cable that you use. Okay, the DB9 and RJ45. One side will go into the router, okay, so RJ45, and you have a DB19. This will go into your laptop for your configuration. So debug commands example, debug all, right? These are commands that are used in when you're configuring the router. Okay, so show version. Okay, command provides general information about device, including its model number, type of interface, its software version, configuration setting, location of IOS and configuration files, and available memories. Show flash command will list the content of flash memory, such as information about iOS files and available memory space in flash. Show running dash config, okay, command to view the running configuration parameter values are created, stored, updated, and deleted from running configuration is stored in the RAM. So basically these are some of the commands. Okay, then show startup config. Okay, any configuration stored in the RAM is released when device is turned off. You can save running configuration if nav RAM. If we have saved running configuration nav RAM, it would be automatically loaded back in the RAM from the nav RAM during the next boot. As switch loads this configuration back in RAM and it starts up device at nav RAM, it is known as the startup config. Show interface command displays information about interfaces. For example, to view details about fast internet, use show interface fast internet. Show up interface brief is an extremely useful command to get quickly overview of all interfaces on the switch. It lists their status, including the IP addresses and protocols. And basic router configurations. Okay, so area of focus, use. Okay, what is it used for? Initialization and reload the routers as necessary. Disable DNS lookup. Configure IP addresses for the routers as per addressing scheme. Configure device name. Assign the console and VTY passwords. Assign the privileged EXE passwords. Configure logging synchronous to prevent console and VTY messages from interrupting command entry. Configure a message of the day and copy the running configuration to the setup configuration. So we have labs for configuring the router. Okay, backup the router configuration file. It is the recommended best practice to maintain backup configuration files for routers and switches in the event that they need to be restored to a previous configuration. Okay, terminal emulation softwares can be used to easily backup or restore a router or switch configuration file. Okay, this is very important to have a backup configuration file. If something happens to the router, you already have a configuration file. You do not have to reconfigure the router. Okay, just upload the file and automatically whatever configuration you had done previously would be restored. Basic router security. Okay, develop a written security policy for the organization. Shut down unused service and ports. Use strong and encrypted password and change them often. Control physical access to devices. Secure remote access. Perform backups and test the backup files on a regular basis. Educate employees about cybersecurity threats and develop policies. Keep software up to date. Configure the static and default routers. Okay, a router uses a routing table to determine where to send packets. The routing table contains a set of routers that describe which gateway or interface a router uses to reach a specified network. Initially, the routing table contains only directed connected networks. To communicate with distant networks, routers must be specified and added to the routing table. We can configure a static route to a specified destined uh, network based on a net hop IP address or exit interface. We can also configure a static default route. A default route is a type of static route that specifies a gateway to use when the routing table does not contain a path for the destination network. So, three, configure and verify the dynamic classless routing protocols. So, Internet Protocol version 4, IPv4. So, an Internet Protocol address, the IP address, is a numerical label assigned to each device connected to a network that uses the Internet Protocol for communication. An IP address serves two main functions: host or network interface identification and location addressing. The Internet Protocol version 4 is one of the core protocols for standard-based inter-networking methods in the Internet and other packet-switched network. And some of the IP address classes. Okay, so we have 5 classes of IP. So you can have, I will not go over this much. We have already covered this in client and server. Okay, binary and decimal conversion. Also, we have looked at it, how numbers are stored in the computer, okay, in binary form, how you can convert numbers from binary and from binary to decimal. The table that you have to use for conversion. So IPv4 address structure. So the IP address gives a device a unique address of a network. The subnet mask used to identify the network and host portion of an IPv4 address. The ones identify the network portion and the zeros identify the host portions. So this is the network portion and this is the host portion. So here, same as for subnet, these ones are the network portions, this is the host portion. So IPv4 address structure, logical, and if you can identify the network address to which an IPv4 address belongs. right? So you have a binary. Okay, this is how the network is in the uh, stored in the computer. The subnet 255.255.255.0. Okay, and you have the result. This is how it is. So the network address becomes 192.168.10.0. So you can see the conversion is 1 and 1 equals 1, 0 and 1 equals 0, 0 and 0 equals 0, 1 and 0 equals 0. So that is how the subnets is, the network addresses are calculated. So the IPv4 address structure, uh, prefix length, so the number of bits set to 1 in the subnet mask, it is written in slash notations given as a backslash followed by the number of bits set to 1. Therefore, count the number of bits in the subnet and prepend it with a slash. So you can see here the 255.0.0.0, it has a slash 8, then slash 16, 24, 25, and that is how it goes on. So if you see these, just don't be confused of what the slash 8 or slash 16 means. Okay, it's basically the bits. So IPv4 host, network host and broadcast. Given a 10.1.1.0/24 IPv4 address, the network address would be 10.1.1.0. First host address will be 10.1.1.1. Last host address will be 10.1.1.254, and the broadcast host will be 10.1.1.255. So note, normally in practice the first host is the default gateway, and in this case the default gateway is 10.1.1.1. Okay, this thing, okay, majority of the time they use the first one as the gateway, the route IP for the router, but mostly sometimes they also use the last one. Okay, so it depends on how the organization structures it. Okay, so IPv4 network host and broadcast, okay, given a 10.1.1.0/24 IPv4 address. So you have your network address as like this. Okay, so your router is 10.1.1.1, goes to your switch. So your first network would be 10.1.1.10, 10.1.1.11, 10.1.1.12 up to 10.1.254. So in this network, given you have a 10.1.1.0/24 IP address, you have the first host starts from 10.1.1.1 going to your last host, that is 10.1.1.254. Okay, so anything in between, those are your usable IP addresses. Right, IPv4 continued. You have your broadcasts, right? So your broadcast would be all the ones in the portion. So of course the broadcast portion will be 10.1.1.255. That will be your broadcast IP address. So unicast, multicast, and broadcast. Okay, IPv4 addressing is assigned to a host. Okay, static. So type in manually, and dynamic. Okay, dynamic DHCP, the dynamic host configuration protocol. That is when IPs are distributed automatically. So IPv4 communication, a unicast send packets from one host to an individual host. Broadcast send packets from one host to all the hosts in the network. Multicast send a packet from one host to a selected group of hosts in the same or different network. Okay, so you have, say for example, 224.0.0.0 to 239.255.255.255 IP4 address are multicast range, and then 244.0.0.0 to 224.0.0.255 multicast for local only, right? So you can have a look at what type of communication is on the right. You have a multicast, broadcast, or unicast. So type of IPv4 addresses, the public and private. Okay, so I'll be quick on this because we've already covered this in client and server. So there is three groups of IPs you can only use for your private IPs. Okay, so that's from 10 and then 1 to 7.16 and 1 to 9.168, right? 1 to 7 is a loopback IP. That means whatever you say on 1 to 7 will come back to you, right? And then link local addresses or automotive private IPs with 169, and telnet IPs are from 192. Legacy classful IP4 addressing started around 1981 but abandoned around the late 1990s. Okay, so this is no longer used now. Classless addressing. Classful are impractical for some networks, does not uh, really need large pools of IP addresses. Additionally, IPv4 is fast depleting because of the classful addressing scheme. So then comes the classless addressing. A formal name is classless inter-domain routing. Okay, CDAR, pronounced CDAR. In 1993, the ITEF created a new set of standards that allow service providers to allocate IPv4 addresses on any address bit boundary prefix, that's the prefix line, instead of only a class A, B, or C address. Allocated IPv4 address based on the prefix length. Okay, broadcast domains. Each router interface connects a broadcast domain. Broadcasts are only propagated within its broadcast domain. So broadcast domain, each router interface connects a broadcast domain. Broadcasts are only propagated within the broadcast domain. Problems with large broadcast domains. Slow network operations due to the significant amount of broadcast traffic. Slow device operation because a device must accept and process each broadcast packet. So reason for subnetting. Okay, solution. Okay, why subnetting is done? Why is it important? So reduce the size of the network to create smaller broadcast domains. Because each broadcast domain connects to a different router interface, each domain needs its own network address space. The process of breaking an address range into smaller address space is called subnetting. Network administrators can group devices into subnets that are determined by location, organizational unit, or device type. Okay, subnetting in IPv4 network. Octet boundaries. Subnets can be created based on octet boundaries, that is 8, octet 16, or 24. Subnets on the object boundary, also known as IPv4 classes, uses the object boundary to separate network from hosts. Classless subnetting uses address bits to separate networks from hosts, allows for much more flexibility. So an example of a classless subnet is here. Okay, creating two subnets with the subnet mask of 25 applied to 192.168.10.0 creates two usual subnets, each one with 126 hosts. Subnetting formulas, okay, use 2n to calculate the number of subnets, use 2h minus 2 to calculate the number of hosts. N is the number of allocated to the network portion of the address, h is the number of allocated to the host portion of the address. So creating four subnets, so a subnet mask of 20/26 applied to 192.168.10.0 creates four equal subnets, each one with 62 hosts. So n equals 2, therefore 22 equals 4, and h is 6, and therefore 26 minus 2, that is 62. And you can go on reading this where we have the subnets for 16 and subnets for 8. The other thing for subnets is if you have all the information, you can just Google. There are subnet calculators where you just put in your IP address and then the octet subnet you want, and it will give you the different subnets that you can create. Okay, subnetting to meet requirements. Okay, subnetting based on host requirements. Two considerations when planning subnets: the number of host address required for each network, the number of individual subnets needed. Subnetting based on network requirements. Administrators may be asked to subnet an IP range to accommodate a specific number of networks. Think of a company with 7 departments where each department must have its own subnet work. The number of hosts per network, while secondary, is also important. Okay, network requirement example. Okay, assume that the range 200.42.98.0/24 was given to the administrator. 7 networks, subnets must be created. Each department will have no more than 29 hosts. A subnet mask of /27 applied to 200.42.98.0/24 creates 8 networks with 30 hosts in each network. Okay, so benefits of variable length subnet masking. So traditionally, subnet masking wastes addresses. Okay, subnetting based on classes is not very flexible, results in wasted addresses. Variable length subnet mask: by verifying the mask, an administrator has more control, less waste. Basic VLSM: a subnet mask of /30 applied to 200.42.98.0 creates a network with 2 hosts in each network. The network 200.42.98.0/30 would be a perfect match for a serial link. VLSM in practice. Okay, consider two routers connected by a serial link. Okay, router A would be 200.42.98.1/30 and router B would be 200.42.98.2/30. 200.42.98.0/30 is the network address and 200.42.98.3/30 is the broadcast address. Okay, structured design. Network address planning. Planning requires decision on each network in terms of size, the number of hosts per subnet, and how host address will be assigned. Planning to address the network. The primary planning considerations are prevent prevent duplication of address, monitor security and performance, provide and control access, assign addresses to devices. Okay, different devices needs may also impact the addressing scheme. common devices are end user device, servers, printers, network devices, and gateways. Okay, routing protocols. Routing protocol can be classified into different groups according to their characteristics. Specifically, routing protocols can be classified by their purpose, okay, interior gateway protocol or exterior gateway protocol, operations, distance vector protocol, link state protocol or path vector protocol, behavior classful, this legacy or classless protocol. So an example is given there. So IPv4 operating protocols are classified as following. Okay, RIPv1 legacy, IGP distance vector classful protocol, and IGRP legacy, IGP distance vector classful protocol developed by Cisco, okay, depreciated from 12.2 iOS and later. So the colorful routing protocol RIPv4.1 and IGRP are legacy protocols and are only used in older networks. These routing protocols have evolved into the classless routing protocols RIPv2 and EIGRP respectively. Link state routing protocols are classless by nature. So Enhanced Interior Gateway Routing Protocol (EIGRP) is an interior gateway protocol suited for many different topologies and media. In a well-designed network, EIGRP scales well and provides extremely quick and convergence times with minimal network traffic. Some of the many advantages of EIGRP are very low usage of network resources during normal operations. Only hello packets are transmitted in a stable network. When a change occurs, only routing table changes are propagated, not the entire routing table. This reduces the load the routing protocol itself places on the network. Rapid convergence types of changes in the network topology. In some circumstances, convergence can be almost instantaneous. EIGRP is an enhanced distance vector protocol relying on a diffused update algorithm, dual, to calculate the shortest path to the destination within a network. Okay, open short path first, okay, is the interior gateway protocol IGP, standardized by the Internet Engineering Task Force and commonly used in large enterprise network. Okay, OSPF is a linked state routing protocol providing fast convergence and excellent scalability. Like all linked state protocols, OSPF is very efficient and in its use of network bandwidth. Okay, routing information protocol. Okay, routing information protocol uses hop count as the metric to rate the value of different routers. The hop count is the number of devices that can be transferred in a route. RIPv2 uses multicast packets to exchange the routing information. Cisco software sends routing information updates every 30 seconds, which is termed advertising. If a device does not receive an update from another device for 108 seconds or more, the receiving device marks the routers served by the non-update devices as unusable. If there is still no update after 204 seconds, the device removes all routing tables entries from the non-updating devices. So fourth one, applying sound troubleshooting process to determine network connectivity. Okay, troubleshoot device configuration and network connectivity using basic utilities. Okay, these are some of the commands that you can use: ipconfig, ping, show interface, show IP interface, uh, trace route, show protocols, show IP protocols, telnet, show running config and show IP route, show IP protocol database, and the network and sharing center in the control panel. Right, identify and correct common problems associated with IP addressing and host configurations. So you can read these two articles on uh, the configurations. Okay, and then perform basic troubleshooting principles to verify the network operations. So basic uh, network troubleshooting steps are: you first identify the problem, develop a theory, test the theory, plan for action, implement the solution, verify the system functionality, and then you document the issue.